So I have some water so we can make some aqueous solutions. I have this wide range pH indicator paper and wide range liquid indicator. Basically, I shouldn't say basically when I'm talking about pH. This has a number of different weak acids and bases that are organic compounds, but they also have one interesting property, and that is that their acid form versus their base form is a different color. Or they are different colors, I should say. And then what we can do is use this indicator Now, I'm going to do a demo for you really quick. This demo is what I want you to write up. Okay? This is the first part of this demo that I want you to write up. I want you to first hypothesize what's going to happen. What I'm going to do is I'm going to take this little pipette that I have the tip cut off of, okay? And I'm going to blow in it, and I'm going to blow bubbles. Okay? I'm going to blow bubbles into that solution that's just water with the indicator in it. And I want you to hypothesize what's going to happen. Is the pH going to remain the same? Is the pH going to go down? Is the pH going to go up? And why? Alright? So, this is the pH breath demo. It's only a subset of all the demos that we're going to do. Are you ready? Wow. So you saw that its original color was pretty much the yellow, right?
Yellow green.
That showed a pH of 7. Now what is the pH?
Closer to 3.
Yeah, closer to between 3 and 5. I can increase the volume of this demo a little bit.
Would you just put in there more water?
I just put in a little bit more water. I'm going to put in a little bit more indicator because I want you guys to all recognize. Alright. I want you to think about why. Concentrated hydrochloric acid is about 13 molar or so. By the way, this is distilled deionized water. Put some indicator on. And we've got what? A neutral solution, right? What do you think is going to happen when I put a drop, 1 drop of hydrochloric acid in here? That's 1 drop of hydrochloric acid. It went from a pH of 7 down to a pH of 3-ish with 1 drop. Add another drop. That's interesting enough. That would make sense because what? Hydrochloric acid is a strong acid. Many of these things were cleaned with basic soap. So what do you think about that?
Yeah, it's still in there.
But probably not very much because watch. There, neutral. So now, what do you think is going to happen when I throw in a little vinegar? So far, we tend to be doing a lot of acid kind of things, don't we? So, vinegar also acidic. This is ammonia, or ammonium hydroxide. What's ammonia? It's a base. What did we have in this beaker? That was the hydrochloric acid one, right? So this is acidic and that's basic, isn't it? What's the deal?
Hydrochloric acid stronger.
Ha!
That's a weak base.
Josh, good man. Did you notice what happened? We had that thing, it was at a pH of 11. I'm going to do that again. It's obviously quite basic, isn't it? It's on the 11 end of the base scale. Now, in there was hydrochloric acid. Now, hydrochloric acid we knew was a strong acid. Is ammonia on our list of strong bases?
No.
Oh, no.
No, it's not. So it must be a weak base. So, when we poured that last batch in, we really didn't see a change in pH, did we? We still didn't. Let's do it again. Well, let's just do it this way, shall we?
Ooh, that changes it.
Oh, what did we do? We finally overcame the strong acid by having an excess of base. Once all the acid is consumed with the base, what's the end? At that very end point, we actually went past neutralization, didn't we? So we titrated that acid with base, and it was leftover strong acid, leftover strong acid, leftover strong acid, leftover strong acid, leftover strong acid. Boom! We went right past to now we have a little leftover base. What happens when I pour this vinegar in here, do you think?
Might become slightly
Yeah.
back over the tipping point.
We went back over the tipping point, didn't we? Where are we at?
7.
We're lucky. What's interesting about this now is that it has parts of weak acids that have been deprotonated, and it has parts of weak bases that have been protonated. And so what we made in this is an interesting compound. And what I'm going to show you, remember before, then you can leave as soon as I do this. I know we're running a minute extra, but watch, and then we're going to continue this demo next week. What's your hypothesis? I'm going to cut to the chase. This is not going to change color. Why? That's the end part of your write-up. Let's do a week from today, in case you're wondering. So the first half of it was I had pure water, an indicator. I blew in it. That pure water changed by 2 pH units, maybe 3. What does that mean? A pH unit is 10 times. So 2 pH units is 100 times. 3 pH units is 1,000 times. So it became 1,000 times more acidic by me blowing on it. It would have happened with you blowing on it too, by the way. I've got no special powers. Well, I do, but not with acids and bases. Anyway, then I went to this solution that had some leftover parts of weak acids and weak bases. It had those weak acid salts and weak base salts, but we managed to get it back to a pH of 7, didn't we? So it had the same pH starting out with as my water did over there. But I blew and I blew and I blew and I blew as bad as the big bad wolf. No pH change. Why? That's the second part of your breath pH lab-like write-up.